Okay, lesson 37 deals with concavity. I am assuming that you have already seen this video and you've already written this down in your notebook and you've looked at what a point of inflection is and you've grappled with those notes and you've already written down somewhere the second derivative test for local extrema and you've worked these questions. It is super important that before you listen to my explanation that you work things through on your own. So here is my explanation for some of what you see. Let's see. Just need to get some stuff out of the way here. Okay, so now we're interested in intervals of increase and decrease, but we're also interested in intervals of concavity. So that means we need f prime, and this, by the way, and we need f double prime. So if you know that, you're off to a decent start. An f prime number line, there are three places where f prime is 0. One is 0. The others are positive and negative square root of 2. And as in the last lesson, this is a cubic, so it starts low, ends high, and in the middle it changes sign twice. So if we're interested in intervals of increase and decrease, f is decreasing from negative infinity to negative root 2, increasing from negative root 2 to 0, decreasing from 0 to root 2, increasing when x is greater than the square root of 2. How is it increasing and decreasing? Well, there are two numbers that make this 0. One is the square root of 2/3, and the other is the negative of the square root of 2/3. This is a happy parabola, so it does this thing. And so if f double prime is positive, f is concave up. If f double prime is negative, f is concave down. And if you were to take your calculator and graph this function, you would see that the function is decreasing, increasing, decreasing, increasing, and you would see that it's concave up, and then concave down, and then concave up again. So this is roughly the shape. I haven't graphed it myself to see if that's exactly the shape. I know that the y-intercept is at 0, 4, so I have some confidence that it looks something like this. Decreasing, increasing, decreasing, increasing, concave up, concave down, concave up. It appears to be roughly what this thing looks like. We'll get a little bit tricky with it. Looking for intervals of increase and decrease, looking for intervals of concavity. So we figure out what G prime is. Oh, yes, derivative of sine x is cosine x. So what does G prime look like? Well, there are lots of places where cosine x is equal to 0. Some of them are negative pi and pi, 3 pi, 5 pi, 7 pi, 9 pi. It turns out, though, that all of these values are positive. So G is increasing, and then it's got a flat tan, and then it's increasing, and then it's got a flat tan, and then G is increasing. So that's odd. That's not something we're used to seeing. G double prime turns out to be negative sine x, and so G double prime has its own way to do things. There's negative pi, there's pi. We'll throw 0 in there for good measure. Between negative pi and 0, that's a positive. Between 0 and pi, that's a negative. Positive, and that goes on, negative, and that goes on, changing every pi. So G is concave down, concave up, concave down, concave up, and so on. Why? If you were to graph this thing, here's 0, here's pi, here's 2 pi, here's negative pi, here's negative 2 pi. What does this function look like? Between 0 and pi, g is increasing and concave down. Between pi and 2 pi, g is increasing and concave up. Between negative pi and 0, g is increasing and concave up. Between negative 2 pi and negative pi, g is increasing but concave down. Increasing and concave down, increasing and concave up, increasing and concave down, increasing and concave up. And so you get this graph all the way through. Horizontal tangent here, horizontal tangent here, but the graph is always up, 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 up. This is a doozy. The first part's actually pretty straightforward because we can make an F prime chart just looking at this. There are three values. Where F prime is 0, at 1, at 2, and at 4. So what does the chart look like? Well, you pick your favorite value that's less than 1, you plug it in, you take the sign of the answer. You take your favorite number between 1 and 2, you plug it in, you take the sign of the answer. You take your favorite number between 2 and 4, you plug it in, you take the sign of the answer. You take your favorite number greater than 4, you plug it in, you take the sign of the answer. So where does F have a local max and a local min? We know that F has a local max where F prime changes from positive to negative. So F has a local max at x equals 2 because F prime changes from positive to negative. Where does F have a local min? F has a local min at x equals 4 because F prime changes from negative to positive. But then there's this business, point of inflection. And to have a point of inflection, you have to have some sort of F double prime chart, and signs have to change on F double prime. Well, how do you get F double prime? You take the derivative of this. So, well, how does that work? Just to make things easier on me, I'm going to write F prime as x squared minus 2x plus 1, that's this part, and x squared minus 6x plus 8, that's this part. And then I'm going to run the product rule on this expression. So F double prime, product rule on this expression, that's first derivative of second plus second derivative first. And then a little bit of algebra gets creative. Oh, sorry. A little bit of algebra. And I'm going to trust that you can do algebra. Where does F double prime change sign? F double prime changes sign at 1, and it changes sign wherever that equals 0. So we find those places, and if the sign changes at those places, those are the points of inflection. This is quadratic formula, I think. That's x equals 1. We were pretty sure x equals 1 was a point of inflection because there wasn't a sign change here. And these are just strange numbers. We find them and we write them down. I don't have to do that because that's algebra. You can do that in the privacy of your own home. Very glad to have worked these through with you. Hope all is well. Keep doing math.